The next speaker, yes, the next speaker is Douglas. He's a computer engineer, graduated from the Federal University of São Carlos, an applicant to a master's degree in the field of computation applied to physics at the University of Campinas. He's been working for just over 3 years as a software engineer in beamline support at the Brazilian synchrotron light source, developing and maintaining EPICS IOCs, LabVIEW solutions, Python scripts, and GUI development. Before that, he worked 4 years as a software engineer in an outsourcing company supporting computer systems for telecommunication companies in the US and Europe. And he's also worked in industry for 5 years, in banking. Okay, over to you.
Okay, thank you very much, Andy, for the introduction. Thank you, all the audience. Thank you. So, I will present a work that was submitted by Gabriel, Fidel, James Piton, and Laís do Carmo. So I've worked together them to implement this solution, which is another approach to develop GUIs. So we in Brazil use EPICS to control devices, mainly with protocols RS-232 in the Ethernet. So I will not enter in this part of EPICS, so I will talk for the upper layers. We have also a Python script that was, in fact, it's a library developed to interact with this EPICS layer, able to produce some scripts to coordinate all the procedures to handle the experiments on all the beamlines we had there. In the Journal of Synchrotron Radiation was published an article on 2015 about this library. So for GUIs, we had an experiences with Java and Python developing the GUIs. So basically Java, we had used CS Studio and LabWeb. And Python, we use TK Inter, and currently we are using PyQt. So just talking about our latest experience in the last 4 or 5 years. For the CS Studio, that has been published in 2007, an article about it, we had implemented a lot of interfaces. Disease sample is one of the more complex we had there. Is in the tomography IMX beamline. It was also present on the latest ICALEPCS on Melbourne on 2015, right? So just to show you the complexity we had on interfaces. The problem we faced with using CS Studio was the interaction with this low level, and in fact it's a middle layer of Python scripts implemented on Py4 thing, because CS Studio is a great tool to interact directly with PVs. We can monitor, we can get and put values, change it. We can produce graphics also. But on the last versions, the versions we were using, the interaction with Python scripts was not so good, so we had faced some performance problems. So the other experience with Java was the LabWeb, was a project to get the Canadian light source and the Canadian government. That was mainly to operate remotely some beamlines we had there. I think this was used mainly for the SACs and absorbance beamlines. This is an example of absorbance beamline. It was working fine, but was just implemented for simple experiments. At the moment, we are not implementing new functionalities or new implementations for the beamlines. We focusing on desktop solutions for GUI to operate beamlines. And then we started some experience is using just Python because as we had a good experience with Python scripts to coordinate and all procedures and the experiments of beamlines, we started to produce GUIs using just Python. So I've presented a paper last year on PCA-PAC on Brazil of implementation using tkinter. It's a pure Python library with some interfaces to start to configure all the parameters of the experiments, to see the results and make some simple and complex calculations. And this example, we had the calibration of a noun sample and a sample during the collection, during the acquisition. So here we had a good experience because we are interacting directly with Python using Python implementation GUI, and I've used pipes on Linux operating system to send information from low-level to high-level interfaces. So we had better performances. And then for the macromolecular crystallography beamline we had there, called MX2, we tried the MX Cube, which is currently being used by the researchers since the end of last year. And they loved the new interface because in the past we had a lot of spread interfaces to control the experiment. So now it's everything in just one place. So MX Cube is, in fact, it is implemented in the way that you can access directly the devices. You can implement sequence and procedures on Python, and you have the widgets on the PyQt graphical stuff. So I've embedded the PyForcing support inside of MX Cube, and in fact, this was necessary to implement all EPIC support because natively it supports Tango, Sardana, Tiny, and for EPICs it was necessary to implement. I will present a paper also this afternoon about our experience there. Again, was a great experience. We had a good performance. So we decided to go ahead using Python on the GUIs, and the paper is mainly about this approach. We had mainly two approaches. One of them was to directly access the PVs to control devices. We are also using PyDM. That is, I think this is also been presented on the conference, right? It's implemented by Slack, the laboratory. One fellows from Brazil that are currently working there are working on this team also. So we are collaborating with them. We are testing and proposing some improvements. It was developed to replace the EDM, that was the extensible display manager. And inside the PyDM, we have mainly the PyEpics, that is a library to access directly the PVs of epics. And wrapping this library, we have the PyQt guys. So we have developed some widgets to offer the objects to control motors or perform scans. And this is one simple example to control the motor. So you can follow the movement. So you could send to an absolute or relative position. You can configure it, whatever. This is another simple example using just the access directly to the PVs. It's an interface implemented to counter vacuum cameras to do the baking process. One of our beamlines there use this process during some preparations to the experiments. And then we had the second approach to this proposal. In this case, we had a server in the middle. So the experiment server will be responsible to wait for requests for two clients in the model of client server. So we could have a GUI implemented in the same way as I've explained it before, using PyQt. In the moment we are using PyQt5. And a direct command sent by command lines for Linux CLI. Inside this server, we will use our PyForcing library that uses internally the PyEpics that directly access the PV, the Epics PVs. So we think that the simpler, the better. So simpler to implement, simpler to maintain, simpler to understand what is happening. And this was the, in fact, we are still working with some experiments using this approach. But it has a great performance because to send requests and receive response from the clients to the server, we are using DBus protocol that has an IPC, inter-process communications, and support also our PC remote process calls. So during the decision, we discussed about the usage of threads or processes. Threads are lighter than process because inherit all the information from the process that started, but process gave us some great control, liability, and you were able to do synchronous and asynchronous controls. So we decided to use process, and that is why we are using DBus. Qt and PyQt has also a Qt DBus library to control these messages transferencing. So at the moment we are very happy with the results we had. We are able to send in the same computer messages from the low level to the high level layers. And we are able to also to start processes from one computer to another computer. Well, had some more deep details about this implementation, but you could access the paper and or send me some questions. One of these interesting details about the implementation is that the Qt and PyQt has also a way to send information from some levels in the GUIs using slots and signals. That is another reason why we used it. So just to show you some samples of interfaces we had at the moment. This is one for perform scans, so user entry parameters, position start, and how many point steppers of steppers of movements between the points. This is another interface to control ocean optics device we had there. And the next steps to finalize, we are looking for a standard to all the beamlines we had in Brazilian synchrotron. We are defining how we will offer the access control to differentiate the staff that is performing the calibration and the final user that is performing the experiments. And we are also thinking how to use web interface, because this approach allows us to change easily this top layer here. So using the same server in Python, to perform more complex experiments, we can easily change the top layer interfaces by, for example, on web implementation. So that's it.
Questions? There's one over there. There's one, yeah.
Thank you for the presentation. I wanted to know what is the experience so far with PYQT, if you're aware of any kind of instability or if there is any kind of a penalty with respect to using Qt directly.
Yes, in fact, PyQt is just a Python wrap to the Qt that is implemented on C, C++, that is available to Python Word using C. So with our experience with MXCube, for example, we didn't had experience any problem with it, so it's working fine. And in the current, this is not in production. It is only been performance. It's been tested performance in our development side. So by now we hadn't faced any instability with it.
Any other questions? There's one. Sergio.
Hi. Well, well, in this conference we have seen already other frameworks using PYQT for control. Did you evaluate any of the existing frameworks before developing your own?
Sorry?
If you have evaluated one of the already existing frameworks for PyQt and controls.
Oh, yes. Except the MXCube, we in fact had tested EPICS-Qt and stuff like that. But as I said, we are looking for some very simple. You said was just to move motors and perform scans and stuff like that. For specific implementations of each beamline, we are still looking for a better approach. But yes, we tested all the approach. And during this conference, I saw a lot of them, also for Tango, for whatever. So I will I will show to them there in Brazil all what I saw and I'm seeing here. Probably will test all the right.
Thanks. Just another this what you did with Qt dbus. It's very interesting. You're publishing somewhere?
Yes, this is being published in a paper. The number of paper is THAPL04. Had a 7 page, so they used the maximum possible. Has a lot of details about the implementations and everything.
Okay, thanks.
Okay, thank you. Thank you, Douglas. Thanks again.
Thank you.